So I was just walking along the street, and a good Samaritan came up to me and was throwing all these chemistry questions at me, and I couldn't understand anything he was saying. He was so frantic. But I did catch a question of his, which was, how does he do addition reaction between an alkene and water and alkyne and water? He knew his organic chemistry skills. He has that, but he's really bad at reactions. So me being the good person that I am, and because I know my organic chemistry reactions so well, I decided to make this video for him and send it to him to help him out a little, because why not? So for this specific addition reaction, we're going to be looking at pent-1-ene plus water, so an alkane and water. Now it has a specific catalyst, which is sulfuric acid at 100 degrees Celsius. So this is the catalyst that will help make the product. So first off, I'm going to be drawing the structures for both of them, and it's pretty easy if, you've learned a thing or two about organic. So these are the two structures, and I put the catalyst right here. And then I marked so this is, of course, what we know as the sigma bond, and then below, and any bonds below will always be pi bonds, and I just marked that with a blue pen to show it. And we're always going to break the pi bond, so gonna circle that, and then we're gonna break this bond between this hydrogen and then this, which becomes a hydroxy. But now, where are we going to place the two of them? Because this can go here, this can go there, that could go there. It can go anywhere, of course. As we learned before, the rich always get richer. So what this means is that hydrogen is always going to go to the carbon that has more hydrogen. As you can see here, these have 2 hydrogens while this has 1, so rich gets richer. This hydrogen is obviously gonna go to this one, which we show with the red arrow, and then this hydroxy will go right there to this carbon. And now we can predict what the products are gonna be. So here I've drawn what this product is, and of course it is going to be a pent 2O as such. But now instead of having pent-1-ene, what if we had pent-1-ine plus water? So regardless if it's an alkene or alkyne, they both will have the same catalyst, the same reactions, regardless if it's one or the other. And as seen here, I just put the catalyst down because it's the same thing. The only difference being with ene, you can have 2 moles of a molecule or just 1. But in this, we just have 1 mole of water. So I quickly drew out the 2 molecules, and of course again I drew the pi bonds in blue and the top being the sigma bond always. And now we're gonna add them together. Of course, that's what this is. So we're always gonna break the pi bond, so just break this bottom one, and again, using Markovnov's rule, the rich gets richer. So it's the same thing that we did before. There's 1 hydrogen here, no hydrogens here, how sad. So this hydrogen is obviously gonna go to that carbon. So we just draw a line. And then this hydroxy group is just gonna go to this carbon, because, well, after the bond's broken, it's gonna have a single bond right there. So now we're just gonna have to predict the products, which is very similar to what we did before. And this is the structural diagram. And as you can see within, you have to specify if it's cis, trans, or neither. And of course here you can see it's a neither situation, because the hydrogen could have been here or here, regardless wherever it could be placed. So you can't really differentiate if it's cis or trans. So we just state it as neither and don't put anything there. So it's gonna be pent 1 in, and we don't put the E because there isn't more than one functional group, so we just do not write that E. So we write 2. Oh, to finish the naming off. See, that was pretty easy, if I do say so myself, with my amazing organic chemistry reaction skills. And now I can go ahead and send him this video. Although now that I think about it, I don't think I got his number or any of his socials. So I am gonna have to somehow find him. Well, that's just great.